Hey guys, and welcome to Conquering Chem. My name is Nathaniel McLean. I am a recent graduate of Coppin State University, class of 2020, where I completed my Bachelor of Science in Chemistry, and currently I'm a first year pharmaceutical science PhD student at the University of Maryland School of Pharmacy. I'm here to help you with your general chemistry problems. I'm doing this one because I have a passion for teaching and I like to tutor, and I did that for all 4 years throughout my journey of undergrad. And even though I'm a busy graduate student now, I still wanted to be able to contribute in some way to undergraduates who might need some type of help with chemistry, but specifically for right now, general chemistry. Without further ado, let's get straight into it. This chapter 1 will be speaking about matter, and specifically matter, the properties and measurements of matter. And for the sake of time, I know that I have a limit of 15 minutes per video, so I divided this chapter into 4 parts. Each part will be somewhere between 8 to 12, 13 minutes. So the first part is actually going to be an introduction, going through the scope of chemistry, the scientific method, the properties of matter, and the classifications of matter, just to give you a good introduction into chemistry. And following this, we will do parts 2 to 4 in separate videos. Parts 2 will be in SI units, part 3 will be density and percent composition, and part 4 will take us into uncertainty and scientific measurements. But for now, let's continue with part 1 and introduce you into the chemistry. So, what is chemistry? Well, really and truly, chemistry is life. When we think about chemistry, we think about chemicals, we think about sometimes maybe even drugs and different medicines and pharmaceuticals. But the reality is, chemistry is all around us. The phone that you're watching this from, or computer or tablet, the lights in your house, everything around you, plants, the sun, chemical reactions are happening up there. Everything is chemistry. So no matter anything you can touch, anything you can see, anything you can feel, it's most likely chemistry involved in there somewhere. So the only way that we can really progress in life and as a human race is to use chemistry to help us improve our lives every day. When we look at chemistry though, we're looking at something called the scientific method when we're trying to do research or scientific experiments. And I'll go deeper into that in the following slide. So what is the scientific method? We'll come to that definition in a few more slides, but we know that it includes deductive reasoning and inductive reasoning. For the sake of chemistry and the science that we're going to be pursuing, we will use mainly inductive reasoning in our experiments, but we'll go through the definitions of both for the sake of tests and quiz. So what is deduction? Deduction, as I have here, is moving from the broad to the specific. You start with an assumption and then draw a logical conclusion. On the other hand, we have induction, which is moving from the specific to something general or broad. You start with an observation, determine a pattern, test the pattern, and then make a broad conclusion, eventually leading us to make a natural law. And so, just to put it into other words, when we're deducing something, we would say that if A equals B and B equals C, then A must equal to C as well. But when we look at inductive reasoning, we're looking at more of a timeline and how much something is repeated or how reliable something is. So we would then say that if A is equal to B yesterday and A is equal to B again today, then tomorrow A is probably going to equal to B because it is a reoccurring pattern that we're noticing. And I have a nice little diagram here to help show you how they link together. So in this example, the first one says that all smart people get good grades, and let's say a guy Ian gets good grades, so Ian is smart, right? But on the other hand, we can make an assumption like all birds have wings and fly, general statement. So if bats have wings and fly, bats are birds. Well, obviously we know that's incorrect. Bats are mammals. But based on deductive reasoning, this might have stood back in the day. With induction, however, which is what we use mainly for experiments in chemistry and science in general, we say that every time we throw something up, that it comes back down. So whatever goes up must come back down. However, if we use that same thought process and say like a person trying to start going to the gym, we say if you do 10 push-ups every day, your arms get sore. So if I continue to do push-ups, my arms will be sore every day. This isn't necessarily true because, as we know, our body learns to tolerate certain exercises over time, and therefore push-ups will actually get easier over time. So overall, we see that the scientific method, given a definition for the sake of quizzes, is the combination of observations and experimentation and the formulation of laws, hypotheses, and theories. And overall, you have to note too that a paradigm, or somewhat a way of thinking, the definition for that would be a model or a pattern of something. And I just pulled it from a textbook because sometimes professors tend to bring these things in quizzes, and it can make the difference between an 8 out of 10 or a 9 out of 10. So moving on to properties of matter. Now, properties of matter, we first have to ask the question, what is matter? And so when you think of matter, I want you to think of anything that you can hold, taste, or smell, because matter is all around us. Matter can be as small as the electrons in an atom to as big as a mountain. Matter is basically anything that we can experience. So some common examples are listed here for you, and it really includes most things. But the harder thing is trying to figure out what isn't matter. So usually different forms of energy tend to be matter. So stuff like sunlight, heat, magnetic force, sound, those are not matter. Now, they may come as a result of the interactions of matter, but they themselves are not matter. Continuing with the properties of matter, we want to look at the composition of matter. So what is the composition of matter? We see here that it is the proportion of each component that makes it up, or the ratio of the parts of a whole. So if I were to ask you for the components of a cake, for example, you might say a stick of butter, 2 eggs, some flour, or a specific measurement, a cup of water, who knows? So you have to think about the properties of matter when you're looking at composition in the same way. So if you look at a water molecule, and we'll go deeper into the definition of molecules, from compounds, from atoms, from elements later on. But looking at the water molecule, we see a water molecule is made up of 2 hydrogen and 1 oxygen. But in what ratio are the hydrogen in there and the oxygen in there? Well, no matter what drop of water you pick up, it will have a percentage of 11.19% hydrogen and 88.81% oxygen. That is the composition of water, for example. Now moving on to the properties of matter themselves. Well, a property is anything that you can observe to be able to distinguish between one type of matter from another. So when we look at those types of things that we can distinguish between pieces of matter or types of matter either by the physical properties or by the chemical properties that they have. Now, a physical property is something more basic, so we can think about physical as, taste, smell, touch, or get even more complex like boiling point, melting point, and all of the other things that are listed there for you. However, chemical properties actually depend on seeing how this piece of matter reacts with something else. So, for example, you can look at the reactivity of what happens when you mix lye with water to make soap, and when it starts to bubble, or put an acid on metal. All of those are chemical reactions that can only be seen by reacting one piece of matter with another. Now, when we look into the classifications of matter, matter can be defined in different ways depending on the parts that we're looking at. So we can be looking at atoms, which are the smallest unit of matter, an element, which is a substance made up of only one type of atom, a compound, which are atoms of different elements combined with each other, a molecule, which is the smallest unit of the compound, a substance, which includes all elements and compounds, a mixture, which is a combination of different substances. A mixture can be homogeneous or heterogeneous, and we'll look into that in the next slide. So here we can distinguish between an atom and an element. So when we look at an atom, we're actually isolating a single piece of an element. So for example, let's say over here, we have an element. This element here might be silver. This is a block of silver, meaning that this is just silver by itself. It is a substance made up of only one type of atom. So all of this here is silver. However, the silver atom would be the single atom that is making up this cube, this chunk, this grinding right here. Now, when we want to distinguish a molecule from a compound, the easiest way to think of it is the compound is the whole and the molecule is the smallest part. So if we had a cake, the whole cake would be the compound and the slice would be the molecule. If we have an ocean, the whole ocean would be the compound and a drop of water would be the molecule. And in this example here, the compound could be water and the molecule would be the H2O molecule right here. Now when we compare homogeneous mixtures to heterogeneous mixtures, The difference between them comes down to how uniform they are. Now, homogeneous mixtures, as you can see here, are uniform and indistinguishable when they're all together. So for example, if you put salt in water and stir it around, you can't see the salt particles because it has formed a homogeneous mixture with the water. On the other hand, a heterogeneous mixture is non-uniform. So if you try to put oil in water, for example, it will never be indistinguishable because the oil will eventually float to the top. Some of it might be in droplets scattered throughout the glass, stuff like that. The same could be said of sand and water, and some uncommon examples of heterogeneous mixtures would be milk, blood, for example, because those can be separated physically into visible components. Moving on to the way that we can separate those mixtures, just like how there are physical properties and chemical properties, there are physical separation methods and chemical separation methods. Now, you don't have to know too much about these, you just have to know the basic difference. Physical separation methods include filtering by separating substances based on things like size and solubility, versus chemical methods of separation, which focus on displacing one atom or a bunch of elements from a compound based on its chemical properties. So for example here, we have copper sulfate having the copper being removed by adding zinc, because in this reaction here, you can't really see exactly what's going on, but the copper is being removed because the zinc is separating it. But basically a chemical reaction is going on. That's all you have to know. Moving on, we all should at this point know the states of matter. You know, we have gases, liquids, and solids. Now the only thing you have to know is some more properties of each. So when we look at solids, these are atoms or molecules that are tightly packed and highly organized and have a set shape. So look here, a solid would have a tight packing, set shape, very organized sample right here. It also takes its own shape and does not conform to the container. Now when you compare solids to liquids, liquids are atoms or molecules that are loosely packed and able to flow. Now liquids take the shape of their container. So that's the important thing to know about liquids. And gases, the final form that we will have to know for this level of chemistry, are atoms or molecules that are free, meaning they have very little interaction with each other and expand to fill the container. So it's not like liquids that take the shape of a container. A gas, for example, could be released at the bottom of a container and it will rise to the top until it fills the container, and if there is no lid, the gas can actually leak out. Through the states of matter, when we move from a solid to a liquid, it's called melting. From a liquid to a gas, it's vaporization. And from a gas to a solid, it's deposition. You can also call it sublimation. Usually instructors would take that. But on the other hand, you have gases going to liquid, which is condensation, and liquids going to solids, which is freezing. And if you want an example of something that goes directly from a gas to a solid, the easiest one and the one that's most commonly used is dry ice, which is commonly used for the sake of making smoke in theater or plays. Dry ice, if you've ever used it before, I had the privilege of seeing it for the first time a little while ago. Dry ice, if you've ever experienced it, starts as a solid, and upon being heated, it goes directly to a gas without passing through the liquid phase. As I said before, I don't want to make these videos too long. This is the end of part 1, where we covered matter and its properties and the classifications of matter. And moving on from part 2 to 4, we'll be covering these topics, the next topic being SI units. So thank you for watching. If you like this video, please like and subscribe. I'll leave some links down in the description that could help you be connected to my Patreon. And in addition, I'll leave my email in case you need to ask me any questions or just to get some of the materials from me directly. Thank you, and see you in the next video.